Hi, in this video, we're going to talk about SLAAC and the IPv6 global unicast address, basically how the global unicast address is created using SLAAC. Okay, so first of all, on the client side, here on Windows, we just say obtain an IPv6 address automatically. And on a Mac machine here, Mac device, we have configure IPv6 automatically. What I want to show you is the difference between IPv4 and IPv6. In IPv4, Mac OS specifically states DHCP. But in IPv6, they use the term automatically, similar to Windows, because obviously it may not use DHCP v6. It might use SLAAC. Okay, so the RA message. So it's sent to all IPv6 devices from the link local address. There's the prefix, there's the prefix length that's being sent. Okay, and we're assuming, I don't have it here, but it should be, we also have the A flag is set to 1. Okay, that's the default. Okay, the host receives this. Okay, says, okay, there's my prefix length. I'm going to use the source address, link local address as my default gateway. Now I need to create a global unicast address because that A flag is set to 1. I'm going to use the prefix and create an interface ID. As far as the interface ID, I can use EUI 64 process or a random 64-bit value. Okay. In either case, I don't use a stateless DHCP v6 server to give me or assign me my global unicast address. I'm going to do this on my own. Okay, so how does it create that 64-bit interface ID? Well, there's two methods using SLAAC. Using EUI 64 process, which we're going to see means it's going to use your Ethernet MAC address. And that means your Ethernet MAC address, which should be pretty much unique in the world. Although we don't use MAC addresses to communicate with devices across networks because they don't have a network portion of the address. But anyway, it is a way to uniquely identify you. So another way that we can do it is to use a randomly generated number known as the privacy extension. Okay. And by the way, different host operating systems will by default do things using either one, but can be modified. I'm going to show you how to modify that on various operating systems. Okay, so let's look at the EUI 64 process. Okay, if the host is going to use EUI 64, it means it's going to use its MAC address to create the address. All right, so what it does is has its Ethernet MAC address, has the two parts, the OUI organizationally unique identifier, which is the vendor, who the vendor is, and usually the model of the interface card, and a unique 24 bits associated with that OUI. So we split that in half. We add 16 bits, FFFE in the middle. So that goes from 48 bits of our MAC address to 64 bits. Now we have almost have our interface ID, the host portion of the address. Next, what we need to do is EUI 64 flips that 7th bit. Now, there's a history behind that. It's known as the universal local bit. I won't go into the history of that. But anyway, it gets flipped. It's really not all that big a deal, whether it does or not, but I won't go there here. So that actually ends up changing the second hexadecimal digit. Okay, so if I do on my Linux PC, do ifconfig, I can actually see some things here. The FFFE here in both my global unicast address and my link local address, that part of it right in the middle of my interface ID tells me, yep, EUI 64 was used, most likely, but I can definitely verify that by looking at the MAC address and notice that it is very similar. or not very, yeah, has the last, there's the last 24 bits, and here's the first 24 bits. Now, there's a 0 in front here, and this second hexadecimal digit, the 2, so that got changed because we flipped the bit. Okay. All right, so yeah, so it tells us most likely EUI 64 was used. Let's see, what else? So we see that we have a second address here. We'll talk more about that in a moment, the privacy. We'll talk more about privacy addresses, temporary addresses coming up in a later video. For right now, let's just focus on the EUI 64 or a random identifier. So here it used EUI 64 in the address. Okay, what about the randomly generated number? Okay, again, by default depends on the operating system. Windows by default uses a randomly generated number. So we can see no FE in the middle. Okay. So the 64 bits was configured randomly, which is going to give you a lot more privacy. That way you can't be tracked. Because the problem is, let me kind of back up here. The thing is, this your MAC address is always going to stay with you wherever you take this device, right? So that means you're going to have the same 64 bits here. No matter what network you're on, you're always going to have this same interface ID. Well, that's a pretty good way of some system wanting to track you no matter where you go, because this is most likely going to be unique. Okay, I mean, it should be unique pretty much in the world. So even though the network you go to might change, they can track you based on your interface ID. And a lot of people don't like that, which is why we have the option for a randomly generated number, which Windows PC does, Windows operating system does by default. Now you can modify that. So Windows default uses the randomized identifier. So kind of looking at this, when it gets the prefix and the A flag set to 1, Windows will generate a global unicast address, okay? But it's going to use the prefix in the RA message. And for the interface ID, it's going to use a random number. Okay. And this is actually the command in Windows that if it was ever modified the other way to use EUI 64, you can set it back to using the randomized identifier by saying randomized identifiers equal enable. So you do it using both of these commands. Store equals active, store equals persistent, but this is the entire command here. Okay. What if you wanted to disable that? What if you wanted your Windows device to use EUI 64? Well, you just disable random identifiers disabled. Okay, so what that will mean is that your global unicast address and your link local address will use EUI 64. Now, there's also a temporary IPv6 address. I'll get to that in just a moment. We're going to have another video primarily on that. But here we can see our IPv6 address and our link local addresses are both using EUI 64 based on the MAC address. Now there is this temporary address that Windows creates by default because it has something else set that we're going to be talking about in the next video. Temporary addresses, they only use a random number. We'll talk about that in a moment, okay? And what the difference is between this address and this address. But for now, all I really want you to see is that your operating system may either use, for the 64-bit interface ID, may use EUI 64 or a random number, and you can change that. Doesn't matter whether it's Windows, Mac OS, or Linux. If you know the right command, you can change it. So Windows by default uses a randomized interface ID. Okay. Okay, Mac and Linux, it really just depends on the version and that. But generally speaking, they tend to use EUI 64. So this is how you can enable the privacy extensions to use a randomized identifier instead of EUI 64 for the interface ID. So check with your specific version of Linux, but Linux OS, that's the command right there, and Mac OS, that's the command. Okay, so we'll talk more about privacy addresses and all this other good stuff coming up in the next videos.